This video addresses two common misconceptions about sampling. The first misconception is that simple random sampling is the only standard for judging the quality of a sample. In simple random sampling, you find a list of all or many individuals in the population. This list is called the sampling frame. Next, you select records from the list without any systematic pattern or bias, such as using a random number generator to pick the positions on the list. While simple random sampling is often ideal, there are situations where more complex sampling, such as cluster sampling and stratified sampling, are necessary to ensure a representative sample. The second misconception concerns complex sampling. While it is a powerful and flexible method for large-scale research, it is not always required for every study. Let's start with the misconception of simple random sampling. Some textbooks suggest that data collected through simple random sampling are always suitable for inferential statistics. However, this assumption can be problematic in certain scenarios. For example, imagine conducting a nationwide study where participants are recruited by randomly selecting email addresses without considering their geographical distribution. This approach might result in an overrepresentation of participants from larger states like New York, California, Arizona, and Utah. But less populated states such as Idaho, Wyoming, and Rhode Island may be completely excluded. To ensure that the entire population is adequately represented, cluster sampling, stratified sampling, or multi-stage sampling often needed. Now we will look into cluster sampling. Cluster sampling divides the population into groups, also known as clusters, then randomly selects entire clusters for study. In this method, all individuals within the selected clusters are included in the sample. For example, first, define the population. In this case, the population consists of all high schools in the U.S. Next, create the clusters. Here, schools are grouped by city. In step 1, you randomly select a subset of cities. In step 2, you survey all schools within the selected cities. This example is highly simplified. In reality, you may want to create clusters by state, county, city, and school districts. This method is efficient when clusters are naturally formed and listing all individuals in the population is impractical. Stratified sampling and cluster sampling are similar, but there is a subtle difference between them. Unlike cluster sampling that accepts all in the subgroup, stratified sampling does not take all. Stratified sampling divides the population into strata, distinct subgroups, based on specific characteristics, ensuring each subgroup is represented in the sample. Elements are then taken from each stratum proportionally or equally. In reality, you may do the selection in multiple levels. For example, first, include all 50 states as separate strata. Next, randomly select a proportionate number of counties from each state. Afterwards, randomly select school districts from each county. Subsequently, randomly choose schools from each district. At the end, randomly select students in each school. This method ensures representation from all strata, which is especially useful when specific subgroups need to be studied. Next, let me explain multi-stage sampling. Multi-stage sampling is a hierarchical sampling method where sampling is conducted in stages, narrowing down the population step by step. In some situations, different sampling methods, stratified and cluster, may be used in different stages of multi-stage sampling. For example, you may randomly select a few counties or cities, a few school districts, and a few schools in each level of the hierarchy. Obviously, this is stratified sampling. However, at the school level, all the grade 10 students are invited to participate in the study. Simply put, all elements in the cluster are accepted. Many years ago, I applied a similar approach in a research study. After selecting the schools, all students belonging to the same grade level from those schools were included in the study. You may wonder why. The reason is, if only some students are chosen but some are but, it might cause resentment among those who left out, thus creating unnecessary tension between students and teachers. In addition, including all students at the same school did not increase the cost of the study at all. Using 50 or 500 students costed the same. In this case, why not use a bigger sample size? Thus, in some situations random sampling is not needed. The point will be illustrated in the next discussion. This hybrid method is useful when working with large populations where listing every individual is impractical. In addition, a combination of different sampling schemes can balance representation and efficiency. The methods discussed earlier are typically used when it is impractical or impossible to contact every potential participant. However, if you have access to the contact information for the entire population, such methods may not be necessary. Let me share an example from my own experience. Years ago, my supervisor assigned me to conduct a campus-wide survey to understand students' perceptions of instructional technologies. I downloaded the names and email addresses of all students and sent out invitations using mail merge. Some colleagues questioned my approach, suggesting we should use stratified sampling by selecting a specific number of students from each college and department before sending the invitations. Their reasoning was that this would ensure all segments of the population were covered and avoid any empty segments. Here's how I explained the situation. Scenario A. If there are 200 students in the philosophy department, I invite all of them to participate in the survey. Scenario B. I randomly select 20 students from that department and invite only those 20. In both scenarios, students could decline the invitation. Which scenario is more likely to result in an empty segment? Clearly, scenario B is more likely to leave out certain groups due to its smaller size. Before the digital age, conducting surveys involved significant costs. We had to print paper questionnaires and mail them through the post office, so we could only afford to select a limited number of participants from each college or department. However, in today's digital era, the cost of sending 500 emails is the same as sending 50,000. All it takes is the push of a button. I hope this video clarifies the misconceptions about simple random sampling and complex sampling, especially in contexts where access to the entire segment of the population or the entire population is feasible. Happy sampling! Mahalo!